First, the record. 2 people died at the scene, and, by the UN Scientific Committee's count, 28 more from acute radiation in the months that followed. The long-term toll is estimated and still debated. We treat it as an estimate with care. We begin here and keep the camera on the engineering. To understand this one, you only need a single number, the number that decided everything. Engineers call it the void coefficient. It answers one question. When the cooling water turns to steam, does the reactor calm down or speed up? In the core, water does 2 jobs. It carries away heat, and it quietly soaks up some of the neutrons that drive the reaction. Control rods soak up more on command. On paper, push the rods in and the reaction slows. Simple. Here is the first flaw, built into the physics. In this design, when the water boils into steam, it stops soaking up those neutrons, so the reaction speeds up, which makes more steam, which speeds it up again. A loop that feeds itself. A positive void coefficient. If you would rather understand why things fail than watch them fail, subscribe. A new failure is drawn here every week, and each one is a reason you are safer than you know. Now the second flaw, the cruel one. The emergency shutdown rods were tipped with graphite, a moderator that in this reactor could briefly increase reactivity as the rods entered. In the first seconds of pressing the panic button, the rods pushed water out of the bottom of the core, and for a moment, the reaction sped up before it could slow down, a brake that taps the accelerator first. Now the load. A safety test, delayed and run at low power, left the core in a poisoned, unstable state, with almost all the control rods pulled out to keep it running. The margin that makes a reactor controllable was nearly gone. To stop it, the operators pressed the scram AZ5, sending every rod down at once. And the graphite tips entered first. The 2 flaws met. The graphite tips and the boiling water both added reactivity at the same instant, and the self-feeding loop ran away. In a few seconds, the power climbed far beyond anything the core could survive. Here is the line. The fuel shattered, the water flashed to steam, and the pressure tore the core open and lifted its cover. Not because nuclear power is uncontrollable, because this core sped up when it should have slowed, and its off switch pushed the wrong way first. The international review was honest about the cause. The earlier account blamed the operators. The revised analysis, INSAG 7, put the design first. The positive void, the graphite-tipped rods, and too little margin to catch any of it. The operators were managing a reactor with design flaws that had not been disclosed to them. And here is what changed. The rods were redesigned so a shutdown only shuts down. The fuel and absorbers were changed to weaken the void loop. The scram was made faster, and limits were enforced automatically. And from this came a phrase now used in every serious industry: safety culture. Failure mode, a reactivity excursion driven by a positive void. A reactor that sped up when it boiled, and an off switch that pushed the wrong way first. Nothing breaks without a reason. Now you know this one. Drawing filed. Like and subscribe to support the channel.